Greetings, welcome to Self-Assessment 7, Problem 3. So solve the following equations, simplify your answers. Where applicable, give both the exact answer and the decimal approximation rounded to 3 decimal places. Show all algebraic work. Okay, let's go ahead and take on part A here. So we notice that we have a logarithm. We need to isolate that logarithm or get it by itself so we can use the exponential form to find out what the value of x is. So to do that, first thing we'll do is subtract 8 from both sides. So we get negative 2 log base 7 of x is equal to 10 minus 8, which gives us back 2. Now we take the coefficient out front, that negative 2, and we'll divide both sides by that. And then we end up with logarithm base 7 of x is equal to negative 1. Okay, now what we need to do is go from logarithmic notation back into exponential. So to be able to read this in English, not in Geek, we know that what this says is log in English says the exponent on. Well, it's the exponent on a 7 that gets me back x is equal to negative 1. So what that says is that 1/7, using the definition of a negative exponent, is equal to x. Okay, now I want you to go in and I'll just show you what to put in, but you definitely need to go check this and make sure it works. So going back into the original equation, get out your calculator and show that 8 minus 2 logarithm base 7 of 1/7 is equal to 10. Or if you think you can do that in your head, do it that way, but I think you should go back and check it on the calculator. All right, let's go take a look at part B here. Now part B is not a logarithmic equation, it's an exponential equation. So we're going to need to use the logarithm to be able to solve for x this time. So our opening move is to isolate the exponential. So to do that, we're going to divide both sides by 1,000. And when we do that, we get 1.12 raised to the x power is equal to 2. Okay, so now what? Well, now we need to go and use the definition of the logarithm to help us figure out what that's equal to. Well, that says the exponent on a 1.12 that gets me back 2 is equal to x. Well, that's cool. We have solved it for x, but they also said where appropriate, round to 3 decimal places. So let's go ahead and do that. So rounding to 3 decimal places, that would look like what? Well, for most of us mere mortals, we're going to have to use the change of base theorem. So we'll use the common log, or log base 10, of 2 divided by the common log of 1.12. And that'll give us our decimal approximation of the value of x. So let's go ahead and get the calculator up here so we can do that. Get out of here, we don't need to be here. So we have the logarithm of 2 divided by the logarithm of 1.12. Let's go check that real quick, make sure we brought that number over correctly. Sure, we did. Okay, looking good. And gives us back 6.116 if we round off to 3 places. Okay, so now what? Well, you could also actually have done this one graphically. So another way to have attacked this problem would have been to enter this side into y1 and this side over here into y2 and then find out where the two graphs intersected each other. I'll leave that for you to do on your own. Another thing is that now that we have that value of x stored into our calculator in the variable ants, if we go in there right now, we'll see if you go second and then come down here to your negation sign there's a variable called ants and it stores the last thing you did. We can actually see whether or not we get 2,000 back by raising 1.12 to that exponent. So if we take 1,000 times 1.12 raised to the ants, we get back 2,000. Okay, well, hopefully you found this useful. That's my sincere hope. Get out there and go do some more problems if you need some help with this, and be sure and post questions to the Q&A forum or to me directly if you need more help.